Hello, welcome to 6.6, Finding Rational Zeros. So we're going to take what we've been learning a step further and a little bit more complicated, but it's super fun. So as you can see, I have my calculator out, so make sure you have your calculator out because you'll be needing that for today's video. So if we're looking at the first one, finding all real zeros, for x cubed minus 4x squared minus 11x plus 30 equals 0. So it says when you aren't given a 0, look at your calculator to find one. Normally, up until this point, we've been giving you a 0, and you would use synthetic division to factor it out, and all would be good. But in this case, we didn't give you one. But if you put this in your calculator and you look to see where it equals 0, that will give you a 0 or an x-intercept. Another word for 0 here. X-intercept. Okay, so let's plug this in. So we have x cubed, so that's x to the third, minus 4x squared minus 11x plus 30. Now make sure, double check to make sure that you plugged it in correctly. Hit graph. And it should look something like this. So when we're looking for our zeros, we can just guesstimate one of these points. We don't have to use our zero function of our calculator. We can just look at that and kind of count to see and then use synthetic division to check. So if we're looking, let's just try, I don't know, this 2 looks like it's a point. 1, 2 looks like it could be an x-intercept. So let's try 2. If we were to use synthetic division and factor this out, then we should get 0 as our remainder if 2 is a solution. So let's try this out. Let's use our coefficients. We have 3, 2, 1, 0, so we're good. So 1, negative 4, negative 11, and 30. So bring down the 1. 2 times 1 is 2. Add those together to get negative 2. 2 times negative 2 is negative 4. Add those together to get negative 15. 2 times negative 15 is negative 30. We got a 0. Awesome. That means it is a factor. Woohoo! So then we know from this that our 2, that gives us a factor of x minus 2, going from our solution to our factor. And again, we just found this 2 by just guessing on our graph here. So then this, these numbers that we have left over, that gives us x squared minus 2x minus 15. And then so from here, we want to simplify this. And we could just look on the calculator, but let's just factor this out. That seems to be easier. So this factors to an x minus 5 and an x plus 3. Alright, so we have our 3 factors. Let's write this out in our factored form. Okay, so we have our f of x. That equals our x minus 2 times x minus 5 and x plus 3. Alright, so remember to find our zeros. We set it equal to 0. And we use our zero product property, so we'll get x equaling 2, 5, and negative 3. Now, one thing that we need to check, and we could have done at the beginning, is we could look, okay, so my degree is 3, so I should get 3 solutions. And look, we got a 2, 5, and negative 3. So we have 3 solutions. So that means we're done. We found all of the solutions for this polynomial. Okay? Sometimes on our graph, we may have some unreal or imaginary solutions. So in these situations, we're just finding the real ones, the ones that actually appear on our graph. So that would make this point, that's our point 2, that's our point 5, and this is our point negative 3. Okay? So let's try another one, scrolling down. So Looking at this one, again, it didn't give us any zeros, but it wants us to find our zeros. So let's plug this into our calculator. Clear this out. Be very careful as you plug this in, making sure you plug it in correctly. Alrighty. Oh, see, and it missed my x, so I'm going to insert that. Okay, so let's hit graph, see what this looks like. Alrighty, so since this is an x to the fourth graph, we should expect it to end going the same direction, which it is, and we should expect to get 4 solutions here. So we definitely have 2, and this may or may not cross over our x-axis, giving us 2 solutions. It may just bounce off, giving us 2 solutions, but only 1 unique solution. Okay, so let's just look at one of these. Let's try to guess to see which one could be. So if we look 1, 2, 3, this kind of looks like it could be at x equals -3. So let's see if this is a solution. So let's use our synthetic division, and if we have -3, so we'll have our 2, 7, -4, -27, -18. Again, we have 4, 3, 2, 1, and 0 as our exponents, so they're all in order. We're not missing any, so we're good to go. So we bring down our 2. -3 times 2 is -6. 7 minus 6 is 1. -3 times 1 is -3. Add these together to get -7. -7 times -3 is a positive 21. Add these together, we get a -6. -3 times -6 is 18. We get 0. Awesome. That means our -3 is a factor. That point actually is crossing at -3. So automatically we know that we have a factor of x plus 3. Okay. So then from this step, let's write this out. So 2x cubed plus x squared minus 7x minus 6. Okay. So then from this step, since we have four terms, instead of using synthetic division again, let's try to see if we can factor by grouping. So let's group these together. Okay, let's pull out our GCF, which is x squared. So we get 2x plus 1. Pull out our GCF. Oh, that's just -1. We'll end up with 7x plus 6. Ooh, these do not add up, so this does not work. So that means we're stuck using synthetic division again. So we can't factor by grouping. So let's look. Okay, we're not really sure about this one. Let's try our factor of 1, 2, or excuse me, our 0 of 2. So let's try 2. And let's choose the numbers that we have here from our first round of synthetic division. So that gives us 2, 1, -7, -6. Bring down the 2. 2 times 2 is 4. 1 plus 4 is 5. 2 times 5 is 10. Add these together, and we get a 3. 2 times 3 is 6. Add those together, we get 0. Awesome. That means our 2 is a factor, so that gives us a factor of x minus 2. And then from here, I'm running out of room, so I'll write it up above. We'll be left with, we started off with we have an x cubed, we divided by an x, so that gives us 2x squared plus 5x plus 3. So from here we need to see, well, can we factor this, or are we going to have to use synthetic division again? So since we have a quadratic, we know how to factor this. Since our a value is greater than 1, we'll have to use our Batman method. So what two numbers multiply to be 6, but add to be positive 5? So when we do that, that gives us our answer of 2x and 3x. Okay, so now we factor by grouping, the Bruce Wayne method. Factor out 2x, we get x plus 1. and we factor out of 3, we get x plus 1. Awesome, but those are the same, so then we're left with factors of 2x plus 3 and x plus 1. Awesome. So now we have our 4 factors. 2, 3, 4. Let's put them all together in our factored form. Okay, so that's f of x equaling x plus 3 times x minus 2 times 2x plus 3 times x plus 1. And from here, we want to find all of our real zeros, so we're going to set this equal to 0. And then just solve for our x's. So when we do that, we end up with an x equaling negative 3, x equaling 2, an x equaling negative 3 over 2, and an x equaling negative 1. And like we said up front, we should have 4 solutions here. And look, we found 4 solutions, so we're good to go. So this also means that at this point, we must have crossed over. We could zoom in to take a look just to be sure. But since we know we have a value of negative 1 and negative 1/2, that's what those 2 points, that's where these points intersect. Okay, those are our x-intercepts, or our solutions, or our zeros. Alright, so let's flip over our page, and don't know why that's there, and try this one. So it says find all possible zeros. Now before, it just said all real zeros, so all the ones that appear on the graph. This is all possible solutions, so this could be real or imaginary. Now, remember, imaginary solutions are not going to appear on your graph, so when you look at your zeros, you can't when you look at your graph and look at your x-intercepts, you're not going to see or you may not see your solutions right off the bat. So what I want you to do is take a second and find a 0 and do synthetic division, and I will meet you at the next step. Alright, so when we take a look at our graph, we can only see 2 intersection points here. So when we use synthetic division, we can just pick one of these. I chose negative 5, so when we do that, we should end up with x cubed minus 4x squared plus 8x minus 8. And we have a 0 here, so that means this negative 5 is a factor. That gives us a factor of x plus 5. Okay, so we know that so far. From here, since we have 4 terms, we can try to factor by grouping. So let's try that out. So we have x squared, and then we'll factor, and we'll have x minus 4. Then let's pull out an 8 here, and we get x minus 1. That does not work again. It's always good to check, because sometimes that will work, and that will save you time. Okay, even though it may not seem like it at this point. Alright, so let's see what other 0 we can use for synthetic division. Oh, let's try 2. It looks like it could be a 0. So a 2, and then we have 1, negative 4, 8, and negative 8 from our synthetic division before. Bring on the 1, 2 times 1 is 2. Add those together to get negative 2. Multiply those to get negative 4. Add those together to get 4. Multiply those, 8. Left with 0. Oh, 2 is a solution, is a 0 here. So that gives us the factor of x minus 2. So then from here, we're going to have to write it out as x squared minus 2x plus 4. Okay, so then now we'll have to look to say, oh, can we factor this? Sometimes we can, sometimes we can't. If we can't, we have to write this in factored form, so I'm going to pause that and do that. Alright, so this is our factored form. Now from here, if we want to find all possible zeros, we'll have to set this equal to 0, and then solve for each of our x's. Now what I want you to do is, for the rest of this homework, is to finish out this problem and come prepared in class to discuss what you should have had for your answer, okay? And that is it. If you have any questions, email me. or else I will see you in class.